Number 7 then from the 2009 Higher Paper 2, a little vectors question. No components, just lengths and angles, so it'll be to do with scalar products and so on. And there was a lot of whinging about this, I recall, after that particular exam. But imagine if you'd got that in your standard grade, and it was just a little diagram like that, a little trapezium, and it said work out some lengths and work out some angles, and that was going to be your scaling trigonometry question. You'd have been laughing at it. Anyway, what have we got here? First part, evaluate this. P dot Q plus R, and then a second one after that. Well, P dot Q plus R first of all. Well, let's just expand that into two parts. That'd be P dot Q plus P dot R for those particular vectors. Scalar product, the projection of one vector onto another. P dot Q means as long as they're radiating from the same point, that has to be careful. We have to be careful about that. It means the length of Q that goes the same way as P times the length of P. The scalar product P dot Q then would be, well, the length of P is 4, the length of Q is 3, and the angle between them is 30. P dot R then. Now, P and R don't radiate from the same point. Strictly speaking, I should consider if I want P dot R, I'll need to have P and then R radiating from where P starts. I'd have to transfer that down there. So that would be P and that would be R. But in this case, it's irrelevant anyway because it's going to be a right angle. And if they're perpendicular, it simply means the scalar product will be 0. Then for this part, what have I got? I've got 12 times cosine of 30, that's root 3 upon 2. 2 into 12 goes 6, so I've got 6 root 3. Next one was R dot P minus Q. So expanding that out, R dot P minus R dot Q. I should really put those little tildes back in to indicate their vectors. Well, there's that R dot P again. Now, strictly speaking, in the diagram they're not correct for this yet because they don't radiate from the same point, but it'd be the same again. If I had R and then I'd put P from the same point, they're still perpendicular, that part's still going to come to 0. But, same way, R dot Q means this. I have to make sure that R and Q radiate from the same point. So if I've got Q going in this direction, I'll have to make R radiate from the same point, so it's going to be coming down here. The length of Q I know is 3. The length of R is another matter entirely. We'll get that in a minute. But the angle between them I can get from this diagram because R was going off from the horizontal at 30 degrees. R was coming vertically down, so that's 90. So the angle between them is going to be 120. So it's going to be the length of R, which I'll have to find in a minute, times the length of Q times the cosine of 120 degrees. Now what about this length of R? Now they're lengths. I've got a geometrical figure. It doesn't matter that they're vectors. They're just lengths in a simple shape. What's the size? What's the magnitude of R? It's the length of that side, ignoring these little arrows and so on. I've got a simple figure that looks like this. Well, that angle's 30, that side is 4, no it's not, that side is 3, that side is 4, I want to know what's the length of this side, which I will just call R. Well, that'll be the same as this side here. I've got a little right angle triangle. What would be that side there if that was 3? Well, that part would make the sine. I would have R upon 3 equals the sine of 30, which of course equals a half. So R is going to be 3 times a half, which is 3 upon 2. So R is 3 upon 2. So what I've got for that is negative 9 upon 2 cos of, now I've got to figure out cos 120. Well, your cast diagram, there's lots of little sketches over here, we'll tidy that up later. Don't really need that part. All sine tan cos, 120 puts you over here. That's 120 degrees. So the effective angle is this acute one to the horizontal, which will just be 60. The cosine, however, is negative there, so it's going to be the negative of the cosine of 60. So negative cos 60, making this answer positive now. So that I've got the cos of 60 is a half, so it's going to be the same as 9 upon 2 times a half, which is 9 upon 4. Of course, normally, if you were just thinking of the scalar product, if two vectors are diverging from each other, so you've got an obtuse angle between them, then there should be a negative scalar product, because the projection of one onto the other is actually facing in the opposite direction. But in this case, you were subtracting it. That's why it's ended up positive. Now, part B says, find the lengths. Now, lengths means you don't need to bother about these little arrows and so on. They're just lengths of lines. You've got a little geometrical diagram. You're just going to find some simple lengths in diagrams that have got right angles and so on. What's the length of Q plus R? Well, first of all, you need to know what Q plus R is. Well, Q plus R simply means you go along Q and then follow that by going down R. If I was to go along Q and then down R, I would end up with this as my resultant vector. That's the vector Q plus R. And if it just wants the length of it, it just means what's the length of that line? Well, let's draw that little triangle out again then. That was Q, that was R, so that's the resultant. That side was 3. That side, remember, it turned out to be 3 upon 2, or you could just use the ratio for the sine of 30, but it's a right angle triangle anyway. So you could either just use Pythagoras or trigonometry. I could just use Pythagoras for this part here. So this side then, which I'm calling Q plus R squared is going to be this then. The length of Q plus R squared will be 3 squared minus, because it's one of the short sides, 3 upon 2 squared. 9 minus 9 upon 4, so that would be 36. Take away the 9, which is 27 upon 4. So that means the length of that side is simply going to be the square root of 27 upon 4. Well, the square root of 4, that's easy enough, that's 2. Square root of 27, well, there's a 9 in there. That's a 9 times a 3, so that's 3 root 3. So it's 3 root 3 upon 2. Nothing scary about that. It was just Pythagoras and a little right angled triangle. Last part then, what's the length of P minus Q? I just need to know where P minus Q is. Well, P minus Q means follow P until you get to the end, and then instead of following Q after that, go against the sense of Q. Well, P was that baseline there. So go along P, and that was for length 4. And then instead of going up at 30 degrees for 3, I'm going to go down 30 degrees at 3. So that was the negative of Q, and that was P. So the result simply means, where did you start? Where did you finish? That's the result. So I've got an angle here of 30 degrees, a side 4, a side 3. I want the length of this side being P minus Q. What does that suggest to you? Scalene triangle, 2 sides an included angle, cosine rule. Cosine rule then. The length of P minus Q squared will be, following the cosine rule, the 2 adjacent sides, 4 squared and 3 squared, minus 2 times those, times the cosine of the angle in between, which was 30. Now, rather than feed that into my calculator to get some decimal approximation, you tend to always look for exact solutions and maybe note the decimal afterwards. So I'm actually going to do this by hand, as it were. So 16 minus 9 minus 24 times, and cos 30 is root 3 upon 2. So I've got 25 minus 12 root 3, which means that P minus Q, the length of it, is exactly the square root of 25 minus 12 root 3, which doesn't require any further simplification unless you want to put down a little note of its approximate decimal value. Which is 2.053 and so on, which I'll just put in a bracket. There it is.